Hello, my name is Eric Segerstrom. I'm a senior electrical engineering student at Rensselaer Polytechnic Institute, working with Professor Luigi Vanfredi's Offset Lab. The following video contains two demonstrations of the Quanser Aero, which is a reconfigurable dual-rotor benchtop aerospace system that I've been working with for the past couple of semesters. Here, the Aero is in its 2 degree of freedom configuration with one of the thruster assemblies rotated 90 degrees. In this example, the Aero is executing a yaw tracking Simulink model that implements a PID controller with a square wave input. The Quark real-time control software that's embedded in the Aero allows for easy integration with Simulink and MATLAB. The provided Quark hardware in the loop blocks allow Simulink to read the current through each motor, read the pitch and yaw angles of the Aero, as well as gyroscope and accelerometer readings in 3 dimensions. These blocks also allow Simulink to write to analog and digital outputs, to apply voltages to both motors, and enable or disable both motors. Here, the Aero is in its 1 degree of freedom configuration, with a 24-volt step input applied to only one of the motors for 20 seconds, and then that input is removed for an additional 20 seconds. The pitch angle is being measured and recorded to the MATLAB WORKSPACE for analysis, and to evaluate several models that were developed of the Aero. The first model being evaluated is a transfer function block diagram model provided by Quanser. So we applied the same input signal to this model and recorded the output. And finally, that same input signal was applied to a functional mockup unit, or FMU, of a physics-based multi-domain model that I developed in Dymola using the Modelica modeling language. We're currently working on optimizing several parameters of this model using Rapid, which is a rapid parameter identification script from MATLAB developed and maintained by Offset Lab. So this plot compares the measured pitch angle of the Quanser Aero, shown in blue, to the outputs of the various models that we evaluated. So the transfer function model is shown in orange, our original multi-domain model is shown in yellow, and then the multi-domain with an optimized damping coefficient in the pitch axis joint is shown in blue. In addition to the configurations that were shown here, the Aero can also be reconfigured to a half quadrotor configuration. However, we have yet to perform any experiments in that configuration. I hope that these demonstrations have illustrated the usefulness of the Quanser Aero in developing and performing system identification and control experiments. Thanks for watching.